The lesson topic for this video is graphing linear equations. And in this video we will talk about all three forms of linear equations, and those are slope-intercept, standard, and point-slope form. Let's remember that slope-intercept form is probably the most recognized form for linear equations, and that is y equals mx plus b. And write down what you need to here. I know a lot of this is review. M is your slope, and B is your y-intercept, and the x and the y represent any point that exists on the line. So there's an infinite number of values of x and y coordinate pairs that will be on the line for this equation. The second form, standard form, probably a little less recognizable, but we use it a lot, is ax plus by equals c. And ax plus by equals c in standard form, again, the x and the y represent any point that exists on that line. And other than that, a, b, and c, we're not going to be talking about specifically what they represent, anything like that, but we will use the numbers that we put in for those variables to help us graph it. More on that in a little bit. And the third type is point-slope form. Point-slope form is y minus y1, that's a 1 there, equals m times the quantity x minus x1. All right, so let's talk about each of those variables as well. M still stands for slope, just like it did here. Okay, m is slope. And then the x and the y that don't have the subscript 1, so not these, but these two here, x and y here, those again are the same x and y from our other two equations that represent all points that exist on that line. And then the x1 and the y1 right here is representative of one specific point that we know that is on the line. And that's why this one, point-slope form, can be so handy, is if we know one point on the line, we can learn a lot about it by using this equation here. Again, more on that as we go. So let's start by graphing an equation in slope-intercept form. All right, so there's the example we're going to look at right there. Y equals negative 2 over 3x plus 6. All right, so the first thing we have to remember is that, again, our slope is the number that is in front of x. Now it's the coefficient of x. Coefficient is the number in front of a variable. So the coefficient in front of the x is our slope. So here is our slope. So we're going to write down m equals negative 2/3. Now if you think about this, it's important stuff here. Right off the bat, remember that if your slope is negative, what is the graph going to look like for our line? Well, it's going to be going downhill. We don't know where yet, but it's going to be going downhill. It will not be going uphill because the slope is negative. So pay attention to that always to make sure if you made a mistake, you can fix it if you see that your slope is going the wrong direction. The second thing we need to know in order to graph is the b value. B stands for our y-intercept, right? A y-intercept is where does this line intersect the y-axis. So where on this vertical line does our graph or our line cross through, right? And b in this case is positive 6. All right, so a way to remember how to use these numbers for m and b to help us graph this line, I always say, let's begin with b and move with m. So if that helps you, you can jot that down. So begin with b and move from that b value using your m value. All right, so we're going to begin with 6 on our, again, y-axis. Right here, 6 is our y-intercept. We know there is a point on the y-axis at 6 because it's our y-intercept. So we begin there, and now we move using this slope. So from this point right here, we know we need to go down 2, because it's negative, and right 3. Remember that slope is rise over run. Rise over run. So we're going to rise negative 2, and we're going to run 3 to the right. So down 2, 1, 2. I'm just going to kind of show you first from here. Down 2 and right 3. Down 2, right 3. So down 2, right 3 will give us this point right about here. And now we know that there's another point on the line right at that location. So we can now draw the line that goes through both of those points, and we know that is our line. And I like to put arrows on the end showing that the line continues infinitely in both directions. Alright, so that's good for now for slope-intercept form. Hopefully that looks a little familiar. Alright, so our second type of line type is standard form. So standard form looks like this. Here's an example. 3x plus 2y equals 12. Notice, looks very different from slope-intercept form. One of the most important things you need to be able to do here as we start the course is recognize the differences between the equations so that you know which route to use to graph them. When you see standard form, you're going to want to always go to what I like to call the teeny tiny table. And we know we can always graph lines using a table for x and y values. We can put a number in for x and find the output for y. Put another number in for x, find the output for y. In fact, we could have graphed this one All right, so the third type is point slope form. And point slope form is probably the least common for you at this point, but we're going to refresh our memory and use it right now. So here's an example. Y minus 2 equals 3 times the quantity x plus 5. Now the reason it's called point slope, as you could probably imagine, is that we're going to find a point from our equation to use on our coordinate plane, and we are going to use our slope from the equation. All right, so what is our point and what is our slope? Okay, the slope should be not a big problem for you right now because, again, m is slope, so our slope is 3. Now the point. Remember that a point is a coordinate pair, an x and a y value. Now we're going to find the two numbers that go in there. So, since we need x and then y, maybe I'll even jot that down really small here. Here's x and here's y. Anytime you write a coordinate pair, x comes first, y comes second. So let's find the x value. Well, here's an x right here. So that's a hint. Wherever x is, whatever's next to it is going to help us fill in our x value for our point. You might be thinking it's 5, but it's not 5. It's actually going to be negative 5. And the reason for that is the general form of point slope form has a minus sign right here. And if that is a minus sign right here, and now it's turned into a plus, what happened is it's actually x minus negative 5 for that minus to be used. So that's why it's going to be negative 5. An easy way to remember this, it's always the opposite of what it looks like it will be. So it looks like it'll be positive 5, but it's actually going to be negative 5. The same exact thing happens over here with our y value. Here's a y, so next to it helps us find our y value for our point. And again, not negative 2, because that negative there is that, so then y is positive 2. So again, the opposite of maybe what it seems like it's going to be. So when this is positive 5, we put that in as negative 5, and when this is negative 2, we're going to put it in as positive 2. Now we have our point, and we have a slope. So let's plot our point, negative 5, 2. So the x value is negative 5, that's over here, this direction, and then positive 2. Our point is right here. Plotting points is super important, that remember how to do it. Let me know in class if you have forgotten your plotting points. So there's negative 5, 2, and we're going to use our slope of 3. Now remember, slope is a rise and a run, like we talked about here. Slope right here. Talk about this rise over run, right? We need to turn this into a fraction, so 3 over 1. This is our rise, and this is our run. So we're going to rise 3 from this point. We're going to go up 3, 1, 2, 3, and we're going to run 1, which will be here. So rise 3, run 1, the point will be right here, and we can now draw the line as such. All right, so a real quick, actually kind of a long overview of our 3 forms of graphing lines based on slope-intercept, standard, and point slope form.